the organization of graphic presentation of data and the organization and graphic presentation of data. So essentially, what is it? The first thing that we should talk about is what your book says. They talk about a demographer. And a demographer is a researcher who looks at population. So things like changes and growths, birth rates, decline, like death rates, etc. A lot of it has to do with population changes, so migration patterns, immigration, emigration. So immigration being things that come in, like groups of folks that come in, emigration being folks that leave, the reasons why, etc. The first sentence of your book talked about it, but doesn't really go into detail. So I just wanted to make sure that you had an understanding of that. But essentially, it's important because a lot of times this graphic presentation is represented through demographic data. So you might have heard the term demographics, right? Which is like race, gender, ethnicity, those types of questions around the understanding of people. And we're going to be talking about visual representation and why it's so important. So there are some examples of visual representations like bar graphs, line charts, maps, frequency distribution tables, etc. On the right here, you can see this is just like a fun little fake bar graph that uses hot dogs instead. And you can tell that on this axis here is where there's evenly distributed values. And then down here are the categories. So in terms of frequency distribution tables, essentially what they are is they're measuring observations in a specific category. So you have like a variable, and in those variables, there's different categories. And it's really the first step toward statistical analysis, because you need to understand, how many things are going on and what's happening. And so the first thing that you have to do is you have to really look at the name of the table and why it's what it's named, what its title is, the number of observations, which variables are there, etc. And it helps us move into the descriptive statistics that we're going to be using and developing over time. So this is your frequency distribution table. We've gone over it, but just as a reminder, your first step is to really tally. In terms of tallying, you don't have to do it necessarily, but if you're doing something, in the moment, the tallying is important. And then you can, you have these two formulas. And so the first is proportion, which is P, equals F divided by N. So in this case, F is your frequency and N is your total number of cases. So if I was doing something where I was looking at the number of majors, this is just made up data that I had, right? Major would be my variable. These are my categories within the variable. The total number of cases would be how many folks responded to my survey, essentially. And the frequency is how many people responded into these particular categories. So I had 4 people that said poli-sci, 3 sociology, 5 criminal justice, 3 journalism, and then 4 child and family development. And then I apply this formula first, right? So 4 divided by 19, 3 divided by 19, etc. Then I multiply it by 100 to come up with my percentage. Which is where all your percentage needs to equal 100. Sometimes, as we found, right, that the rounding can be a little funky. And because of that, you have to figure out which place value you're going to round to first, and then just kind of work with that a little bit, because it does need to get to 100. Okay. So this is for nominal and ordinal, because, you have your major, your variables that are nominal or ordinal measurements with your categorical categories. You can do it for interval ratio as well. So this particular one is a grouped frequency distribution table as one example. It doesn't have to be. You could have like numbers of children, right? So it could be 0, 1, 2, 3, 4, etc. Same process though, where you put the numbers into the frequency here. And then you do the same calculations. So this is the total number of folks that responded. So in this case, maybe it was 26. And then how many people marked that they worked 0 hours? How many people marked that they had 5, etc. And you go down this list. In this case, the percentage, you're doing the same thing, right? Your P equals F divided by N. You can see my cursor. So P equals F divided by N, so your frequency divided by your total. And then you multiply it by 100 to get your percent. And the total of those should be 100. And you will want to calculate them to make sure they equal 100 because sometimes they don't. Cumulative ones are very similar in that you have your frequency and you are doing your percentage, but the difference now is that you're doing an addition to the next row. So you have this row, right, which is 38. Then you did this one individually, which is 19. So you go back to this one, it looks the same, right? So 19. Now what you do is you add it to this one here, because what's happening is that you're trying to figure out, what's the cumulative, like how much of the population or the total or the sample is coming to this. So 38 plus 19 is 57. 57 plus 26 is 83, and you go down, etc. And you'll see that you had to do each individual category, and then you had this total here as you add them to the last row. Just so you know, these up and down are called columns, and then across are rows, just in case there's any confusion with that when I'm referring to those. Okay, so in terms of the linear or Likert scales, in stats, we call them Likert scales. A lot of you have linear scales that you're working with, and you're using Likert scales, which is the rating. I have it down. Oh, oops, sorry. I have it with 3 different variables, but you don't have to do that. So if you pretend that these aren't here, same thing. Now, if you had like 10 of a rating, so like 1 through 10, you're going to want to do it up and down, so vertical, so it looks better and it's more aesthetically pleasing and it fits on your paper. For this, because it's a horizontal landscape, it's a landscape slide for me. That's why I did it across, but you can do it down as well. Same thing, you will be calculating the percentages as well. They're not super different, but we'll do that in person. But same thing, right at the very end, or at the very bottom, you could have your percentages as well. So with your rates, let's talk a little bit about what a rate is. So a rate is when you're looking at a change over time, or how often something is occurring over a particular period of time. That's what a rate is. And what you're doing is you're dividing the number of actual occurrences in a period of time by possible occurrences. So rate is F, frequency divided by population. So let's say I want to look at the rate of criminal justice majors in 2021 compared to the possible occurrences, which is the population of San Diego State in this case. I would do 391, which is the actual number of criminal justice majors who graduated in 2021, divided by 30,865, which is the total population of San Diego State, which is 1%. Now, that does not mean that all of only 1% of the graduates are criminal justice majors. It means of all of the San Diego State students who were enrolled in students in 2021, 1% of them were criminal justice majors who graduated. It also is 1 out of 100 because 1%, right? And that's what that is looking at. So that is that rate. So let's talk a little bit about what do you do and how you look at a table, right? So the distribution table, what it is you're the way you look at it is that you're understanding that it's an explanation of ideas, right? And it's a breakdown of the statistics and percentages of what's going on. It's really telling the story. It's helping you have a better understanding of who's involved with the study, right? Like not in terms of who's doing the study, but who participated, who answered, the population or the sample that you're working with. It tells you which variables were calculated, what questions were asked. And it gives you, what it's about. It gives you a description normally. And you can have frequency distribution tables for multiple variables, but we're not going to worry about those just yet. As an example, if you look on page 37 in the 8th edition, there's a study by Yolanda Padilla and a team of researchers. And you can see that on the top part of it that goes horizontal across, it's broken down by origin of birth. So outside of the US or the US, race, ethnicity, and then on the left-hand side, there are variables. And so in this case, you can do a cross comparison of different variables as they overlap with different origins of birth and race and ethnicity. So this is how you would have different variables across these things. For you, you'll be doing something similar, but we're going to be tackling that next week. And so we're going to wrap up this first part of the video, but essentially it's because we're going to be focusing on the frequency distribution tables at this point. But there are different types of graphical techniques or modes of representation. So you have pie charts, bar graphs, histograms, statistical maps, line graphs, and time series charts, which I will cover more in the next couple of slides. Not all of them are going to be used, but it is a good idea to be able to identify them and recognize them and understand how to read them. So really for this first video, it's important to understand how to create a frequency distribution table for each of your variables and understanding and recognizing how to use them, read them, and create them. Okay, so where we left off was where we created frequency distribution tables, right? And now we're talking about the different types of visual representations that also exist. So the first thing that we're going to talk about are pie charts. We're also going to talk about bar graphs, and then we're also going to talk about histograms, statistical maps, and line graphs, as well as time series charts. For us, we are going to be creating bar graphs and or histograms. We're not going to worry about statistical maps or line graphs, but or time series charts, but it is important that you recognize how to identify them as well as how to essentially read them. So with pie charts, they're very similar to what we've kind of already experienced, which is that it is a matter of frequencies and percentages. And it breaks these down into categories and breaks them down into nominal or ordinal measurements or variables. It could also, we're thinking about it in terms of ordinal or nominal, but it's listing them out as as categories. So instead of saying, necessarily like instead of saying 0.5, it would say, hours worked, and then it would have it broken down by a percentage of how many hours. If we're thinking about our frequency distribution table and we're applying it to a pie chart, what might the one on the right look like? If we're thinking about it in terms of ordinal or nominal variables, right, you wouldn't necessarily have 0, 1 through 5. You would have it actually written out as like, hours worked 1 through 5 or something to that effect. But if we're looking at it as a pie chart, right, the largest portion would be the zeros worked because it's 38%. So just thinking about what a pie chart might look like for your variables, there are options for pie charts already listed on Google Forms. So it's important that you're at least looking through those so you have an understanding of what a pie chart would look like in this case. Now, a pie chart, we've seen a bunch of pie charts online. I'm sure there are a lot of memes that talk about it. And if we're looking at this, you look at the whole, right, which would be 100%. Down the middle would be 50%. This is probably, that would be 75. This would probably be around 60 to 65% of the pie chart. And then if you're looking at the rest of it, right, you would be able to have a general idea of what the breakdown would be. This is probably about 30, let's see. That's probably about 30%, maybe about 30%, maybe 25%. Let's look at it right here. Yeah, that's 25%. So if this is 25%, right, because it's 1/4 of the whole, this isn't quite a full 75%. It gives you an idea, a breakdown of what might be on the pie chart in this case. So your book does say that, says, did you notice that the percentages for several of the racial groups are 3.8% or less? It might be better to combine categories and says to use white, black, and then other and two or more races. Don't do this. It erases people, and it's okay to have small slivers of the pie chart. In some cases, yeah, if it's teeny tiny, it's difficult, but don't erase people when you're doing this and thinking about it. Okay, so the pie chart you would want to use primarily, though, for nominal or ordinal variables. I know that I had the hours worked because that was the table, the frequency distribution table that we covered the most. And you could, but it's best suited for nominal or ordinal variables. And it also is best suited to look at something that is a part of a whole. In this case, this bar graph here looks at book cost. It's a joke, of course. I mean, technically it's a joke. And it has types of books with the cost here. So it does present categorical data to you, as in these are the categories, but it has the number, like the numerical values that are represented with it. So it is frequencies or percentages. So we're looking at rectangles that are of equal width across. And when I say the distribution is equal, I don't necessarily mean the height of the bars are equal, but rather the distribution of the costs are equal. I mean, the distribution, like how the left side over here is distributed across it, that's equal. So, right, 10, 20, 30, 40, etc. It can be horizontal, which is left to right. Right, if you think about it like the horizon, right, left to right, it could be horizontal. But this one is, the bars are vertical. So you can flip them to where the categories would be listed here and the numbers or frequencies are listed here. But a lot of times you'll see it this way. In your book, there is one that is also left to right. So as you can see by this one, right, this is the cost. It's by 10. It says 10. It doesn't have a unit of measurement, so it should say dollars or something to that effect. Of course, it's a joke, right? But you could tell that this is the least amount, so it's under $10. This is at 20. This is under 40, and then this is way too much. Now, you may have seen histograms, and histograms are very different than bar graphs. Now, one thing, and now this is not all the time, but a lot of times what you'll see is that bar graphs, there are going to likely be gaps. You may have two bars that are next to each other, but generally there's gaps between the categories that they're measuring. Histograms aren't so much. The difference between a bar graph and a histogram is that the histogram also presents numerical values. So this is categorical, while histograms tend to present numerical values. It's also showing a difference in frequencies or percentages, but really the difference is you're looking at numerical values. So if we're going back to this, right, technically, not that one, this one, technically, it could be in a pie chart, in a bar graph, a pie chart, but it would likely be better suited for a histogram because the histogram is presenting numerical data. Right, so you can see your age is your numerical data, so it's similar to the one that we have there. It could be hours worked. So that's the difference between a histogram and a bar graph, and you will be creating them as well. Now, a statistical map is a little different, and it's a map that is of statistics. So essentially, right, we're looking at what patterns are based off of geographic locations. It can be done through any unit of measurement, right? Because you're looking at what's happening, what's going on. So if you look at this map here, I should have cited it and where it was coming from, not this one. But if we're looking at this map here, this one here shows the most common languages spoken, excluding English and Spanish, in the United States. So as you can tell, it's distributed across the different parts of the map based off of the language. Now, this one down here is done in percentages based off of the coloring, right? So it says 2.4% are these lighter colors based off of any language other than English spoken at the home. Total share that speaks another language. So basically, any place that speaks a language other than English at home. So this is very, very, very little. Then you go up the next amount right here, which is 10 to 20%. Then you go up 20 and 30%, and then you go up higher to 30 and 44%. So as you can tell, statistical maps give you an idea about geographic location and the breakdown of that. Now, line graphs are also showing differences in frequencies and percentages. So that is one of the things that all of these are doing, is they're highlighting differences in frequencies and percentages. So this one is a joke. It's a funny one, but it does have two groups or more over a time period, right? So it has time period down here, how long you were gone, and then you have your two groups. You have your dogs and your cats. So it displays interval and ratio distributions because you have your time periods here. And it is better suited to compare multiple variables across a period of time. So that is something to look at as you're thinking about line graphs. That might be important for yours. Some of your variables, line graphs may be important or useful at least. Time series charts, you don't have to worry about for yours because we're not doing stuff over a time period. But it is important to at least be able to look at them so you have a better understanding of them. Um, Okay, so it's basically something that, so similar to a line graph on the before, right? It's a change over time with variables. The difference though is that you're looking at very specific points. So if you look at the one before, right, you don't have little dots, and yes, it's looking at over time, but for the time series chart, we're looking at specific periods in time. Your time is labeled on this horizontal axis here. Your variable of interest is up here. So in this case, you're looking at multiple variables. It's not always multiple variables, but it can be. The line graph is multiple variables from before, but this one doesn't have to be. You are looking at periods in time, though, hence why there's little dots. And you're looking at these changes. So in this case, they're looking at the populations of Ireland. So Ireland is a part of Europe, but it's looking at specifically Ireland compared to Europe, which is why there's two. In millions. And so there, these little dots here look at specific periods in time. That's why there's fewer in Europe, as you can see here. And it's looking at this changes over time. So things like population would be important, but it also could be like usage of certain, if we're working for like a public health organization and we're looking at folks who maybe used Medi-Cal, which is the accessible like healthcare for folks who can't afford it. Over time, we might be using some sort of time series chart. And those are essentially all the visuals. It is important that you watch and read all the materials so you have like more support and grounding of that. In addition, think about how you might want to use your, like create your own. So it's a good idea for you to talk to your groups as well as we're moving forward on how you'll create your own as well.